All right, SQL Server fans, I think it's time we get underway. Thank you again for joining us. We're excited to host this June webinar focused on weight stats. Rich Benner is ready to share. Unfortunately, Randy, due to circumstances beyond his control, is unable to join us. We'd hoped to do a tag team presentation, but Rich is flying solo, but he's well equipped to do that. As he joins us from England. It's summer in England this week. So Rich is wearing his Aloha shirt. So mahalo, Rich, for all you had prepared. And I've put a note for those of you who have joined us before. We've continued to have problems with our Q&A module. We've tested it this time thoroughly, and we think it's going to work fine. But if it doesn't, we have a Slack channel where you can enter your questions. And the email that went out about half an hour ago with webinar link had a note for how to join that Slack channel. So if you need it, it's there. Hopefully it works here like it looks like it should. But anyway, I've said enough, and I will now turn it over to Rich and his webinar. Thank you, everybody.
Thank you, Jason. Yeah, welcome to the weight stats webinar, everybody. So we're going to go. We haven't got any demos today, but we got some real life data and some examples to go through. So let's just dive in, eh? So who are SSG? I mean, you all know who we are. Full stack SQL Server consultancy. Long story short, if you need anything, you can get in touch with us. We're happy to help. Okay. So what are weight stats? So they are when anytime anything within SQL Server is waiting for something, it'll get given a wait stat. That can be a query waiting for either a resource in regards to CPU memory. It can be a query waiting for a data object, so a data page, a table, what have you. It can be a SQL Server internal process waiting for something. For example, you have in an availability group, you can have threads that are just sat there waiting to synchronize data across the secondary nodes. Because of that, not all wait stats are bad. Some wait stats just happen. But we'll have a look at what these things are and what they mean for you guys. So just a couple of things to remember. They are cumulative. They are usually in seconds, depending on what you're looking at, or milliseconds. But they're cumulative since the last time the DMVs were cleared, which is usually last server restart. But there are a couple of other things that can do it. But usually it's since your last restart. And we could use them to diagnose quite a lot of things within a SQL Server. So let's go through and have a look at some things. So to get your weight stats, there is a very nice little DMV called DMOS weight stats. It will give you a list. It's worth noting, I pulled this today off a SQL Server 2022 instance, and there were 1,376 weight stats on this table. I work with weight stats every day, and I was chatting with Carlo and our team earlier. I'm pretty sure I could only, off the top of my head, define about 20 of them for you. Because of that, this SQL skills library here is great. If you Google a weight stat, chances are SQL skills will be at the top. And it's a list of 95% of weight stats. Some new ones might not yet be on there when a new version of SQL Server is released. But it's great. It'll tell you for most of them whether it's a benign weight, whether it's problematic, when it's often seen, and for most of them, it tells you how to fix it as well, or gives you pointers at least. In this demo, I will be using SPWho is active later on in this presentation. Sorry, not this demo. SPWho is active, for those who haven't used it, is a beefed up version of SPWho 2. It's basically you put it on a server and you run it, and it'll tell you everything that's running right now. And give you a bunch of information. It will tell you the process ID. It will give you the T-SQL that's been running most of the time. But the reason it's relevant for this is because it will give you any weight stats that query is waiting on right now. So we'll have a look at that a little bit later on. SP Blitz first is very similar. You run that first on a server, it will tell you your current weight stats as one of its outputs. So you can go through and have a look at those. Quite a lot of people will have queries they've written themselves to pull out weight stats exactly how they like. But there's plenty of examples out there, so I won't go through all of those. But if you Google SQL Server weight stat query, you'll find a ton of them. Just find something that you like. All right, so we'll go through a list of common weight types for now. So these are the ones that we tend to see the most, the problematic ones we tend to see the most. So any weight stats starting with LCK is a lock weight. Now this will be on usually a data page. It could be a key lock, it can be a page, it can be a table. But that will be something has locked a data page. I'm gonna refer to it as data page. It could be more than that, but something has locked a data page, and then something else is having to wait for access to that data page. So an example of that could be you've got an update query that's updating a table. You have a read query that comes along to try and read the data. The query is currently the data is being modified, so it's locked. If this is all assuming we're in the default the serializable, not the serializable, what's it called? Isolation level. So as long as we're not in something like recommitted snapshot isolation, that changes this behavior. But assuming we're in default, an update query will block any other query. So reads or other update queries, you'll see them as locked. You can also get there are different letters, and we'll go through that. But you can get LCK MS locks, for example. So that's a shared lock. So a read query will read data from a table. It will take a shared lock, and that means that other queries can read that data, but no other query can modify that data while it's being read. So it's for data consistency. Later on, remember that we'll go through and I'll show you some examples. CX weights, CX packet, CX consumer. All this means is that parallelism is happening in your server. And what that means is you have parallelism settings, which is how big a query needs to be, so your cost threshold for parallelism, and then how parallel it can go, your maximum degree of parallelism. So let's say a query goes, it's a large query, it has a maxed up of 4. It could use 4 CPU cores at once. What CX packet weights happen, when CX packet weights happen, is when you've split your workload across 4 threads, they are processing, and if one completes before the other ones, then it has a CX packet wait, which means it's just waiting for the other threads to finish before the data gets recombined and we carry on with the process. So you will, unless you're running single thread, you will see CX packet waits. It's not a problem unless they're excessive. If you consider them, if it's by far away your highest wait stat, for example, you may want to check things like your parallelism settings. Make sure you're not at the defaults of cost threshold of 5 and maxed up of 0, which is crazy talk. Although I believe later versions of SQL Server may set that correctly for you. So that's CX. Async network I/O is a fun one. We see this on quite a lot of servers. And what this means is that SQL Server has finished processing a query. So an application has requested SQL Server run a query. SQL's done it, got the results set, and it's waiting to send that data back to the application. The most common cause of this is post-processing of data rows. So if you've got your .NET app or whatever, it requests the data. And what you're going to want to do is you want to verify that data when you receive it back. So you're going to run a little check against it, either check that it's within a range, check it against another table. The reason that's a problem is because the .NET app will work on a row-by-row basis. So it will receive one row of data back, validate it, accept the next row, validate it. SQL Server works as sets, so it will do the whole query and try and push it. And the async network I/O will happen when SQL's trying to push the entire query and the application's only accepting a row at a time. So that's the most common cause of async network I/O. And we, like I say, we do see that a fair amount on when we do a health check on a new customer. I'll show you some examples. Latch waits, anything latch EX usually, means that there's a non-page, so a non-data structure lock. So somebody's locking the structure of a table. And somebody else is trying to either read the structure or modify the structure. Page latch is specifically not the structure of a table, but the page data structure. It gets complicated, but you'll often see those together, latch and page latch. And then something like write log, we see quite a lot, not necessarily an issue, but this is when data's modified, you need to harden it to the transaction log until your next log backup happens. If for any reason there's contention on that drive, it may be that you're doing extremely large, like reporting workloads that are trying to write a lot of data at once to the log file, or whether maybe your log file isn't on good disks. Maybe the disks just aren't performing well. Then you'll see write log, where your delay is trying to write to the transaction log. There are a couple of scary wait types that, if you see them, are problematic. So they're known as poison waits, which means that if you see these are bad. These aren't exclusive, but these are the 5 most common ones we see. So if you see SOS scheduler yield wait, that means that queries are trying to get hold of a CPU scheduler so that they can execute. They can go ahead and do what they want, but there aren't any available, so they have to wait. And what happens with a scheduler is then it's constantly switching between all of these processes that are waiting for CPU, and you'll see scheduler yield. I'm sure you can imagine why that's a problem. So it means you've just got no CPU left. You haven't got enough. Resource semaphore is the same thing, but for memory. So when a query, if it needs to do any sort of operation where it stores data in memory, you'll see resource semaphore. A resource semaphore query compile is also memory pressure, but you can't even create a query plan for that query. For the resource semaphore, often what this is you either have multiple or one huge query that are taking a very large memory grant. So the way that memory grants work within queries, and if you look at an execution plan, you'll be able to find the memory grant. But SQL, when it compiles a query and produces an execution plan, it say, I think this query needs X amount of memory to run. It might be 100 meg, it might be 100 gig. And when that begins running, SQL Server will go, oh, you need, if it's 100 gig, you need 100 gig of memory to run. So it'll allocate 100 gig of memory to that query. Now, if you've only got 60 gig on your server, it's going to throw everything else out of memory and nothing else. It's going to give it as much as it can and nothing else can run. Nothing else can get hold of that memory. It might be, you might have 500 gig, but if you've got 6 instances of this query running, even if they don't use all the memory, they get it granted. And that's when you start seeing memory pressure usually. It's usually runaway queries with a high memory grant. And I won't go into too much depth about fixing those, but it's usually extremely large queries, not very optimized, and bad statistics, if you have that in your environment. Right. Thread pool. So it's similar to scheduler yield, but there are a certain amount of worker threads within SQL Server. Each server will have its own number. And an open process, an open SPID, will use 1 or potentially 2 of those, depending on how you're connecting. If you're connected through Management Studio, you will use 2, because one's for Management Studio, one's for the application, one's for the query. Chances are you probably have a couple of thousand worker threads. So if you're seeing thread pool, you've got a lot of processes running on your server, and other queries can't get hold of a worker thread to run. So again, CPU pressure, but that's more of a number of processes running rather than large processes running using a large CPU. The last one we'll talk about here is CMEM thread. This again it's another CPU pressure. We see this mostly when default parallelism is used. So every query is going parallel, every query is trying to use multi-threads, and it's one of those sort of contentions. So if you spend any time looking at wait stats, you will learn which ones in your environment are most common, which ones are problematic, and then we can use that information to go and make our SQL Server more reliable, make it perform better. Okay, so part of what we do at SSG, we're consultants, so we don't necessarily manage our own servers. Well, we have a few, but it's all about customer servers, and it's servers that we may not have seen before. So one thing we do is health checks, and what that is it's a little 2-week project where we will look at one or multiple servers. We have a tool we run that pulls a ton of data, and we'll compile a report about these servers that we've never seen before. Now, part of the challenge of that is the fact that we've not seen it before. We don't know beginning your data structure, your tables. We don't know anything about your servers. One of the things we pull is your current wait stats. From that, we can see what may be the issue on this server that we've never seen before. So it's great for diagnostics. And we've got a few examples of some health checks coming up, of some data we've actually pulled as part of health checks. It's worth noting on these, that second point, that we don't usually get called in on health checks because things are going well. It's usually we've got a problem, and the first thing we do is run a health check, get everything up to a certain baseline, and then see where it goes from there. So that's health checks. Emergencies. So one other thing we offer is a process called SQL 911, where customers can reach out and say, we've got a problem right now. We want you on a call right now. Customers we've never spoken to before, servers we've never seen before. We've got a problem right now that needs fixing. And then we'll jump on. So one of the great things to use for that is wait stats. So like, what are the wait stats? What's the problem right now? And if you see CPU pressure, we'll go down that route. If you see memory, we'll go down that. If you see a lot of locking, we'll go down that route. So it's a good way of, a quick way of saying, where's the problem? So that's for emergencies. And then another service we offer is remote DBA, where a customer may not have their own DBA in-house, and we are their DBA. So as part of that, we will install a monitoring tool, and we will receive alerts. We set it up to send us an email whenever it highlights any sort of problem, and then we'll fix things. So one of the things we monitor there is wait stats. So often we've got one specific customer, for example, who they have at month end a bunch of reports that run, and it gives memory pressure. So we have custom notifications set up for them, so that if their wait stats for memory, so the resource semaphore, go over a certain number, send us an email, we'll jump straight on and start fixing their problem. We can also trend over time. So often a remote DBA starts with a health check. So we'll do a health check, make sure we're in a good baseline, and then we'll manage our servers moving forward. So what we can do is we can say, this is what we were at the health check, this is where we are now for wait stats. How have they changed? Have we got any new stuff bubbling to the top? Is everything settling down like we'd hope? We can trend it, and they're really good for monitoring over time. And I mentioned monitoring alerts as part of that. So it's just you can check the wait stats and say, if I'm seeing this wait stat, it's a problem, and we set up alerts for those. Okay, so this is an example of some of the data we pull for the health check. It's not designed to be pretty, it's designed to be functional. So this customer, we pull this. Remember, these are cumulative wait times. So you can see it's been 1,300 hours since these wait stats were reset. And it's total hours of wait sorted descending. So this customer, async network IO. So that instantly says the application, SQL's performing okay, but it's having problems pushing data elsewhere. So at that point, we go and speak to the development team and explain what async network IO is, why it's a problem, and then they go, oh yeah, we do that. And then we work for a fix, which is usually for the application to accept all the data back and then process the the rows afterwards. Do the validation step as a separate part. They also had latch weights there. So I mentioned latch. At the end, you see EX. That means that it's an exclusive lock, so nobody else can access this while you're doing it. So there's something modifying data structure somewhere in taking locks. So we want to go and look at queries. One of the other things we do is pull your top resource consuming queries. So we're going to look through those for things that are taking object locks. CX consumer is parallelism. It happens. Not too concerned at this point. And then you've got page latch, which is like latch, but for data. We talked about that. Something's taking locks. Not necessarily an issue, but it's something we'd look into. And then you've got your lock weights. So that's your classic blocking. For the different letters, you've got LCK, which is lock, M is modify, and then X is an exclusive lock. So that will be an update query or a writing query. So insert, update, delete. The lock MS is a shared modification lock. So that means that it's a read query reading the data and stopping anybody from modifying the structure while it's reading. We won't go through because if you see the total hours of wait are dropping off. So for this server, we can see they haven't got a ton of CPU pressure. They've got a little bit of SO schedule yield down the bottom there. So we definitely look into that, but chances are that's happening. I from experience, that's usually during like an off hour, they're doing index maintenance or they're doing an ETL load overnight. And we're struggling on CPU, but we have monitoring tools that will tell us exactly when that's happening. Yeah, so this one, we'd say we'd work with the developers. We'd go and find the queries that are taking locks on data and objects, and we work through those as a development task. Sorry, I realized I just talked for ages, Jason, without checking if there's any questions. Have we got any?
No, and I'm not seeing any. And
Okay.
just for our listeners, since we've had problems with this before, if someone could make a comment just so we can see that it's working, that would be helpful. Thank you.
The more sarcastic, the better. We love sarcastic comments. All right, cool. Thank you, Jason. All right, so yeah, for this customer, this is a development item. We've got application work and we've got query tuning to stop them taking so many locks, or potentially look at fixing the locks with an isolation level. And I did briefly mention that, but I think we're going to have time, so I'll mention that a little bit more. What happened? The default isolation level in SQL Server is pessimistic locking. And what that means is that readers won't block readers. So reading queries won't block reading queries. However, readers will block writers. Writers will block readers, and writers will also block writers. And that's for data consistency. So you don't want to be trying to read data which is currently being modified. Now, what some people think is a go faster button is the use of a query hung called no lock. And what that basically says is, go and read this data. I don't care if it's currently locked. Read it anyway. For some queries, you might not care about the accuracy of the data. If you're trying to just present a sum of a row count to an end user, you might not care if that's exactly accurate. But the risk you run with something like no lock is, I'm trying to read a list of users. I'm Richard Benner. I get married to Wetwood as a new surname. If you start reading that data from top to bottom on this table, you'll find me in the Bs because it's sorted by surname. I can then go up and update, say I got married. I'm now Richard Wetwood. You can continue to read the data, and as it gets to the end, you can read me again. So you can get duplicate data. If there was multiple updates, you might read me multiple times. If it was the other way, if I went from a Wetwood to a Benner, you might not read me at all. And that could be really problematic when you actually care about how accurate your data is. The reason people see it as a go faster button is because you don't suffer from any sort of blocking. You're never blocked behind another query. You never have to wait. So by definition, you go faster. But the trade-off is that your data is as problematic. The way isolation levels help is if you start looking at things like snapshot isolation or read committed snapshot isolation. What RCSI will do is if I'm going, it'll turn on a thing called the version store, which is stored in tempdb. If I'm going along and I'm modifying Richard Benner to Richard Wetwood, then what I could do before the update starts, I'll take the row of data as it is and I'll store it in the version store. I'll then go ahead and modify my data. If another query comes along and wants to read that data, it won't be able to read the modified data, but it will get pointed towards the version store and go and read the last good data. So it's still completely accurate. It's just as old as my current update query is to change my name from Benner to Wetwood. So that way you're not going to be blocked, but the trade-off is your data is as old as currently being modified. If you run a large overnight process that modifies a ton of data and takes 2 hours with a lock, your choices are to either wait 2 hours until that process is finished before you read your data. You could use something like no lock or read uncommitted, which just reads the data that's currently being modified. And I have lots of problems with that, but it's an option. The alternative is to use the version store, and then you would read the data and it would be completely accurate. It would just be up to 2 hours old, the data. So it depends on your use case. If you're in a financial application where you want to wait for correct numbers, then you'd stay in pessimistic. If you don't care at all, you can go read uncommitted, you can no lock, please don't. Or you can go with RCSI and just, that's fine. I want to return accurate results. I don't care if they're 2 hours old or however long your longest update query is. So we're seeing lock, which means that we're not in RCSI. I mean, we have other tools that would tell us that anyway. But hopefully we're also not using no lock because we are seeing locks. All right, another example. This is another customer where we got called in for a health check. You can see this server's only been up for 3 days when we pulled our data, which is far from ideal. We like at least 2 weeks, but we pull the data at the beginning. We spend 2 weeks doing a report and monitoring, and then we'll pull fresh data to make sure we're up to date. So you can see this customer, their top wait stat is latch EX, which we know from our knowledge on this course, on this webinar, that's a schema modification locks effectively. The next wait is 6 consumer. So they might have default parallelism. In fact, it's a second wait. I'd be looking at it. OLEDB is one we haven't talked about. I highly suggest we go to sqlskills.com to Google it. But OLEDB is waiting on OLEDB drivers, which is often a linked server or reading data from something like Excel, which some crazy people do. So we'd be looking into that. But then we can see another CX wait, the 6 packet, closely followed by SOS scheduler yield. Now, the combination of parallelism weights being high and SOS schedule yield, which, if we cast our minds back, is CPU pressure, makes me think that they're running with default parallelism, which means every query is going parallel. So it's all going CX weights, and then that's putting pressure on our CPU. So for that, we'd go and verify queries, we'd go and verify their settings, and then we'd suggest appropriate max stop and cost threshold settings, which I won't make you guys sit through me explaining what those are. But it depends on the size of the server. So we suggest appropriately. The only other wait stats of note is things like backup IO you can see, and that's literally backups having to write to disk. You'll often see that when people are writing to file shares or when people are writing to Azure blob storage, for example, if you're an on-prem user or you're not in Azure and you want to write to a cloud storage. Not a problem, as long as you're happy with your backups taking that long. A resolution for that is to back up locally and then have a separate process to put them in the cloud. So yeah, that's this server CPU. So we'd look at CPU pressure, we'd look at parallelism, and then we'd look at queries that are using CPU to try and tune them. All right, last health check example, I think. I haven't got the preview up. So this one, we can see LCKM schema shared locks. So these are specifically, so it's lock, modify, schema shared, and lock, modify, schema, modify. So what this is something is modifying schema quite a lot. Now I remember from looking into this client, and basically what was happening was they will, instead of using temporary tables with a little hash symbol in front, they were using temporary permanent tables. So they were modifying, they were creating permanent tables with a random GUID in the name of the table, and then modifying those, and then eventually deleting them. But there was other sub-processes running. So there was contention on creating, modifying, and deleting permanent tables, effectively, even though they didn't live very long, but they were still permanent tables. So that's why we're seeing schema shared as schema modification locks, because it's locking schema. Async network IO, we've discussed, again, application. And CX packet is parallelism, and lock weights is blocking. The reason I put this particular customer on here is we can attack the weight stats by our most aggressive at the top. However, if you look on the right, this server's been up for 1,300 hours, and we only have a total of 100 hours of lock weights. This server is basically idle. We go and look and see when the lock weights are happening, and whether it's all happening during an overnight process, whether it's happening when they've got a heavy user load. But this, if I pull this, and we did pull this for a customer, I would look at this and go, this server is basically idle. And we don't need to concern with what weight statistics are on here. Okay. Jason, any questions? Keep you
No,
on your
sir.
toes. No,
No, we're
okay,
good.
cool.
And it is
All right,
working, so yes.
perfect. Any suitably sarcastic comments?
No, very tame so far.
Ah, damn it. I was hoping for some corkers. All right. Okay. Where's my cursor? It's there. Now, another thing you can do. So this is all a query that just pulls the DMVs. It does a bit of joining to other tables, but it's basically just pulls the DMVs. This here, these are actual examples of where we've had to deal with a problem and how we approached it. So this one was this output here is the output of SP who is active that I mentioned. So this is you run it, and this takes you a snapshot of when you've run it, and it gives you a bunch of statistics. I have had to white out a lot of them here, but basically this first one is total duration of a running query. The second one is your SPID, your session ID, then it gives you your T-SQL, it gives you your username, and then it gives you your locks. Your weights. So we ignore this top row because this is just the diagnostics that's always running. But we had a problem here where the customer was saying we seem to have an outage, like the website isn't responding. So we come on, instantly run SQL is active. We look at this whole slew of lock weights here and go, these all want, the IX means intent exclusive. So these are all looking for modification locks that are exclusive. So these are actually modifying data. When we look at the T-SQL, which isn't here because it's user data, we could say they were all updates. Update a table where value equals parameter. So they're simple, but they required an exclusive lock. Another thing we get here is you get this blocking session ID, so you can tell which session is blocking when it comes to lock weights. You can see it's mostly 686 here, which is here. So we looked at this, and the lead blocker is this one, which has async network IO weights, which means that it's finished what it's doing. It just can't push its data back to whatever application is trying to receive the data. So in this scenario, I reached out to the customer. This is happening. This process is waiting on pushing data. Turns out one of the applications actually crashed and was basically not accepting the data back. So that explains why we can push the data. So at that point, we killed process 686 and the blocking cleared instantly. All of these queries are very small queries. You can see they've used like 1 tick of CPU, if that. But they couldn't do anything because of the lock on the table. And it's worth noting that had been happening for 3 hours. 2 hours 55 here when I captured this screenshot. So yeah, for instant troubleshooting, it's great for this sort of stuff. Who is active? Load of locks. We can see the blocking here, and we can see async network IO. So there's a problem with an application, probably. Completely separate issues, completely separate customer. Again, 2.5 hours we are at this point. We come in here, we run SV who is active. We can see a load of locks, Intel exclusive. We can see the process that's blocking them, 563. Come across here. This has got a shared lock on a data page. It does show you database name afterwards, but again, redacted. But we can also see that this query has done 7 million ticks of CPU and 3.7 billion page reads, which means it's reading a lot of data. Now, just from experience on this client site, they do sometimes have these large queries, these large reports that take this long. But in this scenario, this is a bit of a runaway. And this allowed us to run who is active, look at the locks, look at the blocks, this query, and it's only 1 millisecond when this was captured, but it was waiting for data pages, which means that it's struggling to read data, which is probably because it's reading a ton of data, and the physical reads are quite high. And just a clarification between these, reads is total data pages read, but that includes data read from memory. They're classed as logical reads, whereas physical reads is we haven't got this data in memory. We need to read it off the physical disk. Physical reads are always terrible performance because disks are slow compared to RAM. So this was our quick summary here was come here, locking, page latch, bunch of reads. Speak to the customer. Are we waiting for it to finish? Like, how important is this query? Some more information that who is active gives you off to the right-hand side. It wouldn't fit on this slide, but it gives you like the host that's running it, the application name, when it was connected, things like that. It gives you a ton of information. But we can instantly see it's locking, how long we've been locking for in milliseconds, and what our lead query is. Okay, this might be the last one. I can't remember. So this one was another problem. Customer came on, things are unresponsive, we can't run queries. Now I ran who's active and saw resource semaphore wait and went, okay. So going back to the poison weights chart, poison weights slide, we know that that's a bad weight if we see resource semaphore. And we know that resource semaphore is memory pressure. It means that these queries here, whatever they are, this one's been running for 1 hour and 16 minutes, and it has resource semaphore weights. I bet if we convert that many milliseconds into minutes, it's probably similar to 1 hour 16. I haven't done the calculation, but please correct me if it's far off. But I would imagine it just can't get the memory to do what it needs to do. But what we can see is we've got 4 queries here which have no weights. So these ones are all running. We can see the top query's been running for 8 hours. These queries, this is the server where I know these are SSRS reports that run. When one or two of them run, it's manageable. From memory, this server has 450 gig of RAM. The query grant for these queries is about 150 gig of RAM. So 2 of them running is okay. 3 of them is putting pressure on memory because 3 queries are running and using no, it's slightly below. It's 450 gig total, and I think it's 140 each. So it's like it's at 420 used by 3 instances. And you've got 30 gig to play with, so it's putting a lot of memory pressure on. But it will allow other queries to execute, so you shouldn't see resource summer 4. But when 4 of them are running, that's it. You're out of time. And we could see that this one had been running for 8 hours, so there was some logic stuck somewhere. So we can come here, we can instantly see memory pressure, 4 queries that are running. Off to the right is how much memory they're using, although it's not always reliable in my experience from the DMVs. Or TempDB allocations is usually a better indicator of how much memory it's using. And we can see our problem queries, the SPIDs. We did end up killing session 337, which gave just enough resources up that these other processes could execute. Like the page life expectancy, which is an indicator of memory pressure, was dropped to the floor. It was like under 100 seconds of page life expectancy. But it got it working. It allowed queries to process, and then we waited for the remaining 3 reports to finish. So again, these 3 issues were P1 issues. And the first thing is to run who is active, which shows us the wait stats, which tells us where the problem is. It's a way of reacting and getting a quick answer to your question as what's wrong, because SQL servers aren't great at communicating that to you sometimes. Okay. Oh, there is another one. So this one here, completely separate issue. Run who is active. We can see the wait info is page IO latch shared. So that means that we're having troubles getting hold of data pages. Sorry, there is an exclusive down here. I take that back. There's an exclusive. So that's an update query. But anyway, queries are having problems getting hold of pages, data pages. What this usually is that you've got one query which is running away, doing a ton of page reads. It's either saturating your network or maxing out the throughput on your disks, depending on your disk performance. So for this one, we can see this top query here is 8 hours, 8.5 hours. It's used 56 million CPU ticks. If we were to go over further, it would show an enormous amount of page reads. So again, a problematic page query. Problematic query, sorry. We could see our wait stats of page IO latch shared. So these are all read queries, just trying to get hold of data pages, and they can't. So that wait stat tells us disk or network caused by an extremely large query reading a ton of data. So again, the actual fix is in your hands, whether you wait for this process to finish, whether you kill it, whether you move data files onto other disks, which isn't an immediate fix, but you can spread your workload across multiple disks. You can, if you're in something like AWS and you've got GB3 disks, then you can just up the performance. You can give them more throughput, more IOPS, things like that. So the fixes are within your hands, but what the wait stats will do is tell you the problem. If you come here, and if you don't know what page IO latch SH is off the top of your head, you type that in to Google. The top result will be sqlskills.com. You'll click on it, it'll tell you what it is, why it is, and then you can decide on how to fix it from there. So again, lots of information you can get from wait stats that will help you diagnose a server. I love weights. I don't, but I love the information you can get from wait stats. They'll tell you what's wrong 95% of the time if it's a performance issue. Cool. I think I just motored through that, and we're a little bit ahead of schedule. So, do you have any last questions, Jason, or any first questions?
No, still not seeing anything, but obviously we can stand by a minute and see if they anything
Yeah,
pops up.
cool. And yeah, if there aren't any questions, we will be sending out these slides afterwards. And yeah, you've got our email addresses if you need to get in touch for anything. We're here, and if you want to talk about weight stats, I'd love to. If you can't tell, I do love the sound of my own voice. It's the accent. It even gets me, you know.
Oh, yes. Well, as we're standing by a minute, let everybody know that July and August we will not have a webinar. Everybody is extra busy in those months, it seems. So we won't try to jam in anything. Most likely we will be back with something mid-September, which seems to be our usual schedule. Maybe October, but probably September. And then obviously we'll share that as soon as we pick a topic and a date. And yeah, start making you aware.
I heard that Kyle volunteered for the next one. He is here to defend himself, whether he's going to realize he's muted.
It's a common name. You'll have to specify.
Yeah, good save. Good save.
Yeah, well, I know Randy is eager to do one, but the last few times he's been scheduled to partner with you, Rich, and it just something's come up, unfortunately.
I'm starting to take it personally, you know. There's only one common denominator here, and it's me. You know.
Well,
yeah, no, he's it's unfortunate, but yeah, he's indisposed. Bless him.
yeah. Well, I think if we don't have any questions, we might as well let people go and they can get back to their busy days and or maybe the West Coasters can head out for lunch or something like that. But just appreciate everybody joining us. Thank you for your time, Rich. And yeah, happy to if you come up with a question after the fact, you can always email us and be happy to get you an answer in due course. So yeah, with that, I guess we can say have a great day and until next time.
Thank you, everybody.